Hello, this is Nusrat Hurain, a first year second semester student of Computer Science and Engineering Department at Bangladesh Open University. This is the final project of Digital Logic Design Lab. Our topic is how to design a 2-bit ALU. So before designing, let's have a basic idea on ALU. What is ALU? ALU stands for Arithmetic Logic Unit, which is a digital circuit that performs arithmetic and logical operation on binary numbers in a computer CPU. So from this definition, we came to know that an ALU must have two units. One is arithmetic operation unit and another is logical operation unit. And we all know that arithmetic is an elementary branch of mathematics that studies numerical operations such as addition, subtraction, etc. And the logical operation is the branch of mathematics that tests the relation between true and false values. And a 2-bit ALU means all these operations will be performed only for 2-bit binary numbers. This is the very basic schematic diagram of an ALU. We already know that an ALU must have two units. One is arithmetic operation unit and another is logical operation unit. The input will be same both for arithmetic unit and logical unit. The arithmetic unit will give us an output and the logical operation unit will also give us an output. And from these two output, we will select only one output which will be our final output. This is the more detailed schematic diagram of an ALU. In arithmetic operation unit, we will do two operations. One is addition and another is subtraction. And in logical operation unit, we will do two operations. One is AND operation and another is OR operation. The addition will give us an output and the subtraction will also give us an output. And from these two output, we will select only one output, which is the output of our arithmetic unit. And in logical unit, the AND operation will give us an output and the OR operation will also give us an output. And from these two output, we will select only one output, which will be the output of our logical unit. And lastly, from these two output, I mean from arithmetic output and logical output, we will again select only one output, which will be our final output. So this is the final circuit, which idea we have already got from the schematic diagram. So in this circuit, there are two portions. The upper portion is the arithmetic unit and the lower portion is the logical unit. In arithmetic unit, we will do two operations. One is addition and another is subtraction. And in logical unit, we will do two operations. One is AND operation and another is OR operation. The addition will give us sum as an output and the subtraction will give us difference as an output. And from these two output, we will select only one output by using our 2:1 marks, which is the output of our arithmetic unit. Similarly, in logical unit, from the output of AND operation and the output of OR operation, we will select only one output by using our 2:1 marks, which is the output of our logical unit. And finally, from these two output, I mean arithmetic unit output and logical unit output, we will select only one output by using a 2:1 marks, which is the final output of the circuit. Now for better understanding, we will see this circuit in Logisim. Let's go there. So this is exactly the same circuit that we have already seen, but it is in Logisim. So in this circuit, there are two inputs and this is 2-bit binary numbers. And here is another extra input which is 1-bit binary numbers and it is not connected to the logical unit. So in the case of full adder and subtractor, we know that except these two inputs, they need another input which is called carry or borrow. So it is only applicable for arithmetic unit. Now I will show how I designed this circuit. So at the top of the Logisim there are many things. This green one is called input and this one is called output. So all these inputs and outputs of this circuit I collected from here. Now I will show how I connected the inputs and outputs. First of all, I select on the input, then I will drag it here. Now we are seeing that it is a 1-bit binary input. If I want to modify it, I want to go on the left side of the Logisim. Here we are seeing that the data bits is 1. If I want to modify it, I need to click on it and then select the bits. If I select 2, then it is a 2-bit binary input. This way we can in this way we can connect and modify the output. Now I am deleting it. The adder and subtractor I collected from arithmetic section. Here all the elements of arithmetic operations are available. I collected these gates from the gate section. All the logical gates are here. I collected the marks from the flexor section. See, this is the multiplexer. Like the input and output, we can modify all the elements of the circuit. We can set the data bit for all these elements. This is very simple to connect. If anyone have a very basic idea of Logisim, they can design it very easily. Now, we will simulate this circuit to see whether it works properly or not. To simulate the circuit, we must select this icon. First of all, I will change the carrier borrow. As carrier borrow is only connected to the arithmetic unit, in that case, the logical unit will not work. So to change the carry, our sum is 0, 1 and difference is 1, 1. And as we selected 0 in marks, therefore our arithmetic unit output is 0, 1 because our sum is 0, 1. If we select 1 here, then our output will be 1, 1 because our difference is 1, 1. To see the response of logical unit, now we will change the inputs. I am selecting 1 here. Now our sum is 1, 0 and difference is 1, 0 and our arithmetic unit output is 1, 0. And in that case, in logical unit, our AND operation output is 0, 0 and the OR operation output is 0, 1. As we selected 0 in marks, our logical unit output is 0, 0. If we select 1 here, then our output will be 0, 1 because now our output, our OR operation output is 0, 1. And lastly, as 0 is selected in these marks, our output is 1, 0 because our arithmetic unit output is 1, 0. If we select 1 here, then our output will be 0, 1 because our logical unit output is 0, 1. So in this way, 2-bit ALU works in a computer CPU. That's all about for today. Thank you.